I don't know. It's like,
So like I said, we're going to use product to sum and sum to product identities to do the same thing we've been doing the last few days, and that is evaluate trig expressions and solve trig equations. Okay, last day of identities. Alright, so on the sheet I gave you, bottom right hand side, you've got the product to sum and the sum to product identities listed. So those are the ones we're going to use today. So here's our first problem. And it says, our directions on this problem say rewrite each product as a sum or difference. So we have a product, we want to use a formula to rewrite it as a sum or difference. So which formula does this match?
cosine A, cosine B.
Cosine A, cosine B. So that means this is going to be equal to 1/2 of cosine of 3 theta minus theta, and then plus cosine of 3 theta plus theta. So all I did was plug it into the cosine A times cosine B formula. So that means we get 1/2 cosine of 2 theta plus cosine of 4 theta. And we have done what the problem asked us to do. What did it ask us to do? What did I say the problem asked us to do?
To go from
Rewrite it as a sum or difference. Have we done that? Yes, we've rewritten it as a what? As a sum, since we're adding together. So that's all they're wanting you to do there is plug it into the formula and rewrite it as a sum or difference.
That's what we do.
All we do on that problem.
That can't be.
Okay, this time we've got numbers so we can actually evaluate the expression. So we have 2 times sine of 135 times sine of 75. 2 times sine of 135 sine of 75. So which formula do we have here?
Sine A, sine B.
Sine A times sine B, which is only that part. So that means the 2 has to stay here, and then I need to put my formula in for the other part. So this is sine A, sine B. So it would be 1/2 cosine of A minus B, so 135 minus 75, and then minus cosine of A plus B, so 135 plus 75. So all I did there was plug it in. Yes?
There, I saw it on here. I was just reading it wrong.
So what happens to the 2 times the 1/2?
Cancel.
It cancels out, so now, what's cosine of 135 minus 75? 60? And then 135 plus 75? 210? Okay. We should be able to evaluate both of those. What's cosine of 60? 1/2. And what do I need to be able to evaluate cosine of 210? Okay, so what's my quadrant? 3. What's my reference angle? 30. So what's cosine of 30? Square root of 3 over 2. And what's cosine in the third quadrant? Negative. So what's the best looking answer here? Very good. 1 plus the square root of 3 all over 2. And what is it that equals 1 plus the square root of 3 all over 2?
2 sine 135 sine 75.
Very nice. 2 sine of 135 times sine of 75. Good. Alright, now this one, I had a mistake with writing it. That 3 is not supposed to be here. It's supposed to be there. So this is 3 sine of 17 pi over 12 minus 3 sine of pi over 12. And this time we want to find the exact value of this expression. And what formula do I need on this one?
Sin A minus sin B.
Sine A minus sine B. Now, there's something we need to do before we plug it into that formula. What is it we need to do? Factor out of 3. And what else would you recommend we do? Put my angles in degrees. So what does pi over 12 equal?
15.
And what's 15 times 17? It is 255. So now I'm ready to plug it into the sine A minus sine B formula. So that would be 3, and then we're dealing with sine A minus sine B. So that would be 2 cosine of A plus B. So 255 plus 15 over 2. And then times sine of A minus B. So 255 minus 15 over 2. So what happens to 3 times 2 up front?
Should
6.
that be fine?
Say it again.
Is that second one signed?
Second one's sine, isn't that right?
Yeah.
Yes. Alright, so 255 plus 15.
270.
270, and 270 divided by 2. 270 divided by 2. 135. Alright, 255 minus 15. 240 and 240 divided by 2. 120. So now I want to evaluate each of those. So what do I need to evaluate cosine of 135? So what's my reference angle?
45.
45. What's my quadrant? Second quadrant. So what's cosine of 45? What's another version of 1 over square root of 2? Square root of 2 over 2. And what is cosine in the second quadrant? Negative. Okay, reference angle and quadrant for 120. 60 and quadrant. Second quadrant as well. So what's sine of 60? Square root of 3 over 2. What's sine in the second quadrant? Positive. So we multiply this out. I get negative 6 square root of 6 over 4, which reduces to what? Negative 3 square root of 6 over 2. And what is it that equals negative 3 square root of 6 over 2? That's what we started with up there at the top. Very good. All right, one more. We want to use a sum to product to help us solve an equation. So we want to solve 3 cosine of 5 theta minus 3 cosine of 4 theta. Three cosine 5 theta minus 3 cosine 4 theta. What do you guys recommend? Factor out of 3. Let's do something better than factor out of 3. Divide by 3, since it's an equation. So that means I'm looking at cosine 5 theta minus cosine 4 theta equals 0.
I get it. Yes.
So now I've got a cosine A minus cosine B. So that means we have negative 2 sine of A plus B. So 5 theta plus 4 theta over 2. And then we have sine of A minus B. So 5 theta minus 4 theta over 2. Matthew.
How does that work? Because, and I know we're not doing this to solve it, but if we move that cosine of 4 theta over, cosine of 5 theta does not equal cosine of 4 theta.
It will for a particular theta.
Thetas are weird.
There is a theta that we're getting ready to find out that I can plug in that will make those two equal to each other. Alright, so what about this -2? I can divide by it and it goes away. So we're looking at sine of 9 theta over 2 and sine of theta over 2 equals 0. So now what can I do? I don't need to change them. I've got two things that are multiplied that equal 0. What can I do? They're already pretty much in a factored form. What do we do after we have things factored? Set them both equal to 0 is what we can do. So sine of 9 theta over 2 equals 0, and sine of theta over 2 equals 0. So when does sine equal 0? Zero and pi. And notice it does not have 0 to 2 pi up there, so what does that tell me I have to do with my answers? Plus 2 pi n. So 0 plus 2 pi n and pi plus 2 pi n. But I'm interested in what theta equals, not 9 theta over 2. So what do I need to do to get theta by itself?
Multiply by 2, divide by 9.
Multiply by 2 and divide by 9. So 0 times 2 is 0. 0 divided by 9 is still 0. But I have to do the same thing to the 2 pi. So 2 times 2 pi is 4 pi, and divided by 9, I get 4 pi over 9. Okay, same thing for the pi. Multiply by 2, divide by 9. That's 2 pi over 9. And the right side is still going to be 4 pi over 9. So there are my first two solutions. Do the same thing on the other one. Okay, so it's still going to equal the same two numbers to start with, 0 plus pi, 2 pi n and pi plus 2 pi n. But on this one, all I have to do to get theta by itself is what? Multiply by 2. So that's 0 plus 4 pi n and 2 pi plus 4 pi n. So, back on what Matthew was saying, at this point right here, if I move one of them over, I get cosine of 5 theta equals cosine of 4 theta. So it should make sense that if I plug 0 in, I get cosine of 0 equals cosine of 0. That was pretty easy to see. Okay. So let's plug 2 pi over 9. If I plug 2 pi over 9 in there, that gives me cosine of 10 pi over 9. And if I plug it in here, that gives me cosine of 8 pi over 9. So I'm assuming that if I take my calculator out and I need to be in radian mode, that those two things will equal each other. Let me check that for you real quick.
Looking too minus column.
Alright, cosine of 4 times pi divided by 9 is 0.173, and cosine of 10 times pi divided by 9, that one didn't match.
Boom.
Just like, hello.
Digest.
2 pi. Let me make sure I did that right. It's a good question. Let me see what the book has on this one. 3. Now it could be because I wrote the problem down wrong. I'm not going to get a match. I'll check, but it should work. It should have worked. I know this one. I know the 2 pi is going to work, but I don't know. I need to double check that one. I'll check that. All right. Assignment makes 352, 38 to 54 even. 38, 54 even.
Well, it says the line, maybe no, I changed it. Cervical pubic